All right, let's just dive right into this explainer and unravel a huge biological mystery. It's one literally every single one of us has experienced at some point, right? Today, we're going to look at the actual science behind why being left out, ignored, or rejected just stings so incredibly much. Like, we all know the feeling, but right now, we are getting into the hard neuroscience of a broken heart. So we're actually going to start our detective story way back on the kindergarten playground, with this famous rule introduced by William Paley. You can't say you can't play. It's such a simple rule, but honestly, it's this really powerful reminder. That palpable relief of not being excluded, it's universally understood, even when we're just tiny kids. It was as if her students had been completely rescued from loneliness, given this safe haven from a universally dreaded human experience. And that brings us to a really massive scientific mystery. Think about it. Why is the vocabulary of physical damage pretty much the only way we can describe this feeling? Why does an invisible, purely emotional experience actually feel like a physical blow to our very core? Why does it hurt? Well, the crucial point we're exploring today is this concept called the physical-social pain overlap. And this is a totally groundbreaking theory. It essentially says that your brain, literally, cannot tell the difference between a broken leg and a broken heart. The idea is that the exact same neural circuitry your brain uses to process physical pain, it got completely hijacked to process social pain. Now, to prove this isn't just some poetic metaphor, we're going to walk through three distinct pillars of really rigorous scientific evidence. We're looking at linguistic commonalities across cultures, pharmacological cross-treatments, and actual neural brain imaging data. Basically, we'll look at how we talk, how our bodies react to drugs, and finally, what our brains actually look like inside an fMRI scanner when we're feeling left out. Let's move to our first clue here. Just think about how we talk about this stuff across totally diverse languages all over the world. We use the exact same vocabulary to describe social pain as we do a physical injury. Like, we constantly complain of hurt feelings or broken hearts. There really is no other way to describe socially painful experiences other than, using these physical pain words. And that offers our very first hint that these two systems are fundamentally linked. Moving on to pharmacology, animal studies reveal something pretty incredible. It turns out that low, non-sedative doses of physical painkillers, stuff like morphine and other opiates, they actually reduce the distress vocalizations in infant mammals when they're separated from their mothers. And this is true across dogs, monkeys, guinea pigs, and believe it or not, even chickens. And in humans, we see that antidepressants normally prescribed for anxiety or depression from social stressors are now super commonly prescribed to alleviate chronic physical pain. The neurochemistry is totally overlapping. Okay, before we look at the brain scans, we need to know the prime suspects in our brains. So physical pain actually has two parts. There's the sensory part that tells you where you're hurt, and then there's the affective part that makes you actually care that you're hurt. The dorsal anterior cingulate cortex, or DACC for short, and the anterior insula. These are the specific regions that process that unpleasant, distressing feeling of suffering. In fact, chronic pain patients who have portions of these areas removed, they can still feel exactly where an injury is, but the pain just doesn't bother them anymore. So to test this neural overlap, researchers had to somehow recreate that playground sting of rejection, but, inside a laboratory. So they put humans in brain scanners and had them play this virtual ball tossing game called Cyberball. The participants totally thought they were playing with two other real people, but it was actually just a preset computer program. And partway through the game, the virtual players suddenly just stop throwing the ball to the participant. They purposefully exclude them. And wow, this brilliantly illustrates the smoking gun. On the right, you're looking at a brain experiencing a painful physical stimulus. But on the left, that's a brain simply being excluded from a virtual game of catch. The pattern is almost identical. Being excluded lit up the exact same DACC and anterior insular regions as literal physical suffering. What's even crazier is that the participants who reported feeling the highest levels of social distress during the game, they showed the highest spikes in these specific brain regions. Now, this revelation leads to a really bizarre question, one with some mind-bending consequences for how we treat our bodies. If physical and social pain use the exact same underlying system, what on earth happens if we take factors that alter one kind of pain and see if they affect the other? And that brings us to the manipulation hypothesis in action. Researchers found something absolutely wild here. Changing one type of pain automatically alters the other in a completely congruent way. Like if someone shocks you on purpose, an intentional social slight, it physically hurts you more than if it was just an accidental shock. Or if researchers give you an endotoxin to cause physical bodily inflammation, you suddenly report feeling vastly more socially disconnected. And as incredible as it sounds, providing social support directly decreases the sensation of physical heat pain. Let's see how all this builds to what I think is one of the most fascinating experiments in modern neuroscience. I mean, just think about it for a second. If social and physical pain are really this tight knit, Could an everyday, over-the-counter physical painkiller be used to soothe the emotional sting of a broken heart or social rejection?
Well, researchers put this directly to the test with the Tylenol protocol. In this study, one group of participants took a daily 1,000 milligram dose of generic acetaminophen. You probably know it better as Tylenol. And they did this for 3 weeks. Meanwhile, a control group just took a placebo pill. And every single night, all of them tracked their daily emotional hurt feelings in a diary. So, the crucial point is what emerged by day 9. By the 9th day of this study, the average participant in the Tylenol group was reporting significantly lower daily hurt feelings than those taking the placebo. While the placebo group saw zero change in their emotional resilience, the group popping a physical painkiller literally became measurably less bothered by daily social slights. How wild is that? A follow-up fMRI study with a higher 2,000 milligram daily dose proved this completely visually. Participants did the Tylenol protocol and then played that cyberball game while inside the scanner. And the results were just astounding. Tylenol literally dampened the neural activity in the brain's social pain centers. Remember, the DACC and anterior insula? When participants were excluded, an actual physical painkiller actively cooled down the brain's emotional suffering. And guess what? The reverse works beautifully too. Just as a physical painkiller can reduce social pain, a social painkiller can reduce physical pain. Researchers found that women subjected to a painful physical heat stimulus reported significantly less pain if they were just holding their partner's hand. But it gets even more amazing. Just looking at a photograph of their partner measurably reduced the distress of the burning sensation compared to looking at an object or a stranger. It's truly incredible. We even see this overlap wired straight down into your very DNA. Look, we know there's a specific variation in the OPRM1 gene. It's called the G allele that literally makes people more sensitive to physical pain. Like, they actually require more morphine after surgery. But researchers found that individuals carrying this exact same gene variant also score much higher on trait sensitivity to social rejection. Their brains light up with way more distress during that cyberball exclusion game. Basically, if you're genetically predisposed to feel more physical pain, you are absolutely genetically predisposed to feel a broken heart more deeply too. Okay, so we've proven the overlap is completely real, right? From language to pharmacology to brain scans and genetics. But to fully resolve our detective story, we have to ask the ultimate functional question: why? Why would evolution design our brains this way? Why make a social snub hurt just as badly as a broken bone? Well, the answer lies in our survival. Because human beings are born relatively immature and completely defenseless, we have to rely solely on a caregiver. To a mammalian infant, being separated from the group literally means certain death. So evolution didn't even bother building some entirely new system to warn us about social danger. Instead, the attachment system just piggybacked directly onto the already existing physical pain system. It uses the pain signal itself to sound a massive, unignorable alarm whenever our vital social connections are threatened. So I want to leave you with this final thought. We so often treat a broken heart or hurt feelings as this weakness you just need to get over. But the intense pain of rejection, it's not a flaw in your design. It is a brilliant biological adaptation that promotes the exact social bonding that has kept humanity alive. Your brain hurts because it's doing exactly what it was designed to do, keeping you connected and keeping you safe. So does knowing that change how you might view your next heartache?